Thank you very much, Ben.
Thank you. So Mark introduced Future Fuels as being smart, exciting and sexy. There's 3 people in our team, so you can decide for yourselves which adjective I deserve, if any. So our team's the Maritime Futures team. So we deal with kind of general horizon scanning, more the broader picture, and which kind of vessels we use, which fuel in the future. So there are obligations overall. We're accountable to the Secretary of State for Transport to make sure that we have coastal state obligations, so search and rescue, so the Coast Guard, counter pollution, got well represented here, hydrography, and safety navigation, and so on. Our flag state obligations, so the regulation of shipping and safety standards, crew welfare, training, and medical health. And finally, the port state obligations as well. So the inspection of ships, the enforcement of the rules and checks on port safety practices, all of which are fairly well wrapped into alternative fuels. So just to give an example, several organisations interplay whenever you're working at a port. And for example, we remain responsible basically for the vessel. So you can have bunkering from shore to ship, from truck to ship, from ship to ship being particularly common. And if it's ship to ship, the MCA would be responsible for both ships, both the bunker barge and the ship. Otherwise, it'd be responsible, of course, just for the ship. And then and for any refueling from another ship to the port. And then interplaying with all the other port authorities as well. So in terms of the vessel types and likely fuel options going forward, it very much is about embracing a multi-fuel future with no one fuel really working for everything at all. So things like ferries, aquaculture, workboats, inland and recreational vessels, limited range, and then characterised, particularly in this case, by having lots of recharging opportunity. That may well suit electrification. If you can electrify, you probably should. It's the most mature technology. It's relatively straightforward. So the offshore wind operation and maintenance fleet is also a bit of a unique case because they've got access to potential charging from the turbines. So basically taking electrification and then giving it a massive boost in effective range from being able to recharge out and then also accessing cheaper electricity. And then for longer range domestic vessels, so things like longer range ferries or maybe crew transfer vessels that have longer range and so on, that's when you might find yourself using compressed liquid hydrogen. But most people think that compressed liquid hydrogen will be restricted to smaller vessels because the challenges of doing hydrogen at scale are very large. The storage costs are extremely high, and it's very, very difficult to get a liquid hydrogen system to be, even remotely leak-free. At the international level, most signs are pointing towards methanol and ammonia in some mix, with methanol sort of being the preferred fuel, except for the fact that there's going to be real issues around scalability of methanol in terms of accessing a sustainable carbon atom. So it's, pretty much all the predictions suggest that methanol would take by 2050, sort of a 20 to 40% kind of market share, and ammonia would be around sort of 50 to 70%, with the rest made up of other things. So essentially, we need to prepare for all of these fuels in terms of how they might be released to the environment and how we deal with them. So hydrogen on board is flammable and explosive, but it does actually vent upwards and diffuses fast. Now this slide, I keep meaning to update, and whenever I present this slide, I keep noticing the mistake. But tank on top design is basically preferred at the moment. That's where the conversation is going. Having hydrogen below deck, even with the best explosion-proof venting, at the moment is tending towards being too unsafe. So Class have rules around hydrogen already. They're certain to evolve, and the MCA is going to develop those for coded vessels over the next few years. So as I said, liquid hydrogen considered by many as too difficult and too low energy density for the international, but there are some backers, some nations, some companies are backing it, but they are the minority. So you need larger engines to work hydrogen, and if you can put a fuel cell on board, which is a lower power density form of propulsion, then that is a natural pairing. So the UK does plan to be part of the European hydrogen backbone. That's industry plans rather than government plans. That will mean that we might be able to access piped hydrogen, which would be, once the pipeline is installed, the cheapest way of getting it around. We have a lot of UK hydrogen generation products, thanks to DESNZ's 2030 hydrogen strategy. Most of these are blue hydrogens, taking reformed natural gas and sequestering the carbon dioxide afterwards. So methanol, so it's toxic on skin contact or if you ingest it. It burns with invisible flames, so you need special cameras to pick up fires and so forth. because it's toxic to humans, you maintain a 600 mil exclusion zone around tanks before you get to any human occupied space. You also have double wall pipes and tank inerting and so on. The IMO have released interim guidance for its use as a fuel, but very much in development towards a final set of rules. And again, Class have developed rules for this. Methanol is less aquatically toxic than conventional fuel by several orders of magnitude. So actually, you can store methanol in a single skin tank, where ordinarily you'd have a double bottom. So actually, you can make use of that space on a retrofit. To burn methanol, you need 5% pilot fuel or some kind of combustion promoting additive to burn it in a diesel engine. Methanol you'll see appearing probably on both small and large vessels, but again, the challenge of methanol is getting hold of it. Again, that sustainable carbon atom to get either sort of so some kind of green or biomethanol. The infrastructure requirements are relatively straightforward, but are different to conventional fuels, and you need twice as much space to store it, and possibly twice as long to bunker, because you're bunkering twice the volume of fuel to get the same energy. And generally, we try and caution people around choosing methanol because other people are choosing methanol. It needs to be linked into some kind of supply agreement. And that's where most of the successful projects are, because again, there's no guarantee this is going to be available at scale to transition like a very serious chunk of the sector. So ammonia, obviously a gas at ambient conditions, highly toxic to humans in small quantities. It's not particularly explosive or flammable, not to be confused with ammonium nitrate, but it is very toxic to aquatic life. But then it breaks down quickly. So at the point of release into the water, it's our understanding that it would kind of kill everything it touches, but it would break down quite quickly after that, and it wouldn't present a long-term risk. Ammonia can be stored as a liquid at temperatures of just -33, which is a lot easier than -253 for liquid hydrogen. Our view is ammonia will probably predominantly seen on international vessels. And the reason for that is you need high levels of containment and leak mitigation. And to get those in efficiently in the vessel and to actually fit them in at all, you're probably looking at quite a large vessel. Things like water curtains, highly trained crew, and so on. There's no current UK low carbon ammonia production, but there are plans in place. Again, the reason you end up with ammonia rather than methanol is just this availability of that sustainable carbon atom. You can make ammonia just from water and air. So regulators and the IMO are actively working towards rules for this, for safe implementation on ships. And there is an order book for ammonia. It's small, but it does exist. So batteries still create lots of stir in the press. Generally, maritime battery installations are pretty safe. Nowadays, the rules are still evolving. Things like DNV, for example, having come out with a rule relatively recently said you shouldn't store more than 5 MWh in one A60 enclosure. If you have more than that, there's a risk the enclosure won't hold if there's a full thermal runaway. So if you're going to have very large installations, for example, this Bibby Wavemaster vessel, which I've just waved on somehow, will have, say, multiple times of that on board. You need to separate that in separate rooms. So there's a few different types of battery. They have different risk profiles. Nickel manganese cobalt is the conventional one for automotive. It's also the most risky of the ones that are getting used in maritime. Lithium iron phosphate is made of more abundant materials and has a slightly better safety profile. And then lithium titanate is another alternative. It's more expensive, but the cycle life is very, very high. It's sort of maybe 30,000 cycles instead of like somewhere between 1 to 10,000 cycles, and could actually outlast the vessel. So in some cases, a very high cycle life vessels could be a cost-effective option. That's by far the most safe of these options as well. You're not really going to see other types of battery like sodium emerging into the maritime sector because they have fundamentally lower energy density. And maritime is a demanding sector for energy density. So it's going to be lithium. And as I said, the rules are pretty mature. MCA's got Workboat Code 3, so anything under 24 meters that's a workboat can be coded, use us as a one-stop shop, and we now have prescriptive rules for how to use batteries on board. And so biofuels, classed by generation typically. So first generation are made from edible crops, so directly compete with food. Second generation are made from waste products, do not compete with food, supposedly, depending on but you know, that do have to be quite careful with where you're tracking your supply chain. So both things like hydrotreated vegetable oil and fatty acid methyl ester, FAME can be first or second generation. And in fact, FAME is commonly called Eucomi, so use cooking oil to specify that. And then finally, nuclear. So maritime sectors focusing on small modular reactors. So 4 main options: light water reactors, fast neutron reactors, graphite moderated high temperature reactors, and various kind of molten salt reactors. I'm just going to carry on talking like I can remember which each of those is. So obviously nuclear has got an extremely high cost associated with it in its development, as well as safety and security concerns. I think nuclear is one of those things that we have to keep an open mind about, but I think in terms of its actual application on a civilian vessel, commercial vessel, it's one of those things that personally I think I'm going to believe it when I see it. But we do have an advanced nuclear fund to actually invest in next generation nuclear technologies, which would apply to both land use and maritime use. It's a highly regulated environment. You're going to have to deal with that number of pieces of legislation, guidelines, and conventions, and multiple considerations on board: safety, security, exclusion zones, access to fuel, how you manage the waste, and so on. So that was an extremely rapid whiz through future fuels from the MCA's perspective.
Thanks, Ben.